How to write code for insertion in linked list. In the last lecture, we learned how to insert a new node into a linked list. Here, whatever procedure we learned in last lecture, we are going to see how to convert it into code. That is, if you want to implement this procedure, how are you going to write a code for insertion in linked list? This is what we are going to learn here. What did we learn in the last lecture? If you want to do this insertion, whatever be the position at which you want to insert, you should stop your traversal one step before the actual position of insertion. After that, you should have your new node here, and the next pointer of your new node should point to whatever is pointed by the next pointer of the one in position before the position of insertion. Then the next step is to change this next pointer and make this point to your new node. This we explained in detail in the last lecture. Here we are just going to see how can you write a code for this. Let us say your function is this one. You want to insert into the linked list. How do you identify a linked list? A linked list is identified by head pointer. So you will have a head pointer which will identify the linked list. What else should be there as parameters, the arguments in this function? It should have a position. So there should be one particular position at which you want to insert. So that is called as position. After this, whatever be the value that you want to insert, that is the value. What are the arguments? One is the head which will point to the linked list. Then you have whatever be the position at which you want to insert, and what is the value that is to be inserted. These are the requirements for this function. What is the first step for insertion? We learned that whatever be the position of insertion, first step always remains the same. That is, you should create a new node. Let us say node is equal to, here you want to create a new node. I'll just mention that you have to create, what should be data? Your data should be equal to the value. The data inside the new node, that should be the value that is passed to this function. After this, we learned during insertion at a specific position that in case the insertion is happening at beginning, what should you do? You should treat it as a separate case and handle insertion at beginning. This is because if you want to insert at beginning, what do you want to do? You want to make the next pointer of the new node point to whatever was previously the head node. After this, the head pointer should be modified to point to your new node. This is to be done. Because of this, we have to treat this as a special case. So if your position of insertion, if that is 0, if this is equal to 0, this means insertion is to be done at the beginning of your linked list. How will you handle this? For this, first step is the next pointer of your node has to point to head. How will you write it? It is node pointing. Node means whatever you newly created. Node pointing next. That is the next pointer of your node. It will point to the head of your linked list. Head means whichever was the first node of your linked list, that is what will be pointed by head. So your new node will now point to the head node of your linked list. After this, what is the next step? The head pointer, this should now point to the new node. So this is equal to your new node. Now this head pointer will point to your new node. After this, you can return your head pointer. In case insertion is to be done at beginning, at this point your code is done. But in case it is not, that is, if it is not the beginning position, then what should you do? You should keep traversing through the linked list and go till the position which is the position before the position of insertion. If you want to insert at third position, you should stop at 2. This is the rule. How can you do this? You will have your current pointer, you will have a current pointer, this will point to the head. So head is the starting of your linked list. We'll start from the beginning of this linked list and we have to keep traversing. Current is equal to head and we'll have an index. Index is equal to 0. Why are we having this index? We are having this because using this index, we'll keep track of the position. And what should you do? Whatever be the position that is passed to this function, that is, here we passed a position to this function. Whatever be that position, one step before that position, you have to stop your traversal. How can you do that? For that, you need to write a while loop. In the while loop, what should be done? First check is make sure that your current node is valid. Current is the pointer using which you are going to traverse through the linked list. So when you move on to the next nodes in your linked list, your current pointer will be moving forward. That is why I'll have a check for while current. What does this mean? When I simply write while current, this means while current is not null. So if whatever is pointed by current, that is a valid node, you can continue. Otherwise, in case current is null, that means you already reached the end of this linked list. That is why it is pointing to null. So in that case, you should stop traversal and whatever is the position mentioned, that is invalid position. Otherwise, if your current is a valid node, then you have to do one more check. That is till the point you reach position -1, that is till the point you have to keep traversing. So while current and what is the second condition? Your index, this index will keep incrementing in the while loop. Till the point this is lesser than position -1, you can keep looping. Why is this position -1? This is because we want to stop at the position which is before the position of insertion. So this position, it is the position of insertion. You have to stop one step before that. That is why we are having position -1 here. What should you do inside this while loop? Inside this while loop, you have to keep going to the next nodes. How will you do that? You will say current is equal to current pointing next. This means whatever be the present node you are standing, this is presently pointed by current. You will make your current pointer point to the next node. This is what this line means. After this, one more thing is you have to keep track of position using index. For that, you should increment index as well. So your index, this will be index equal to whatever is your present index, that plus 1. So you are moving to the next node and you are incrementing index. This is what you have to do inside the while loop. Outside the while loop, whenever you come out of the while loop, what does that mean? There are two possibilities. One is that the current node is null. Whenever that happens, you already reach the end of the linked list and whatever be the position that is provided for insertion, that is invalid. That is what it means if you came out of this while loop because of this condition, that is current is not valid. Otherwise, if it came out because of this condition, that is index less than position -1, that means you actually found the position. That is, you reached the position, your index got incremented and reached the position which is just before the position of insertion. So what should be your next step here? Next step here is you have to first verify whether it came out because of this current. If it came out of this current, that means the position is invalid because your current is null. What can you do now? You should write if current equal to null, or you can say if not current, that is current equal to null. In that case, what will you say? You will say the position is invalid. You can't do anything. So you will simply return head without doing insertion. This is because insertion is not possible. So you will say it is invalid and then you will return the head. Otherwise, if it is not the case, that means current is a valid node and you have an option to add the new node as the next of current. So if this is what current is pointing to, you should add your new node in the next position. How will you do that? For that, your node pointing next. This is what we learned in the last lecture. Whatever be the next pointer of your new node, that is node pointing next, that should be made to point to the next of your current node. So this will be current pointing next. What does this step mean? This step means current is presently pointing to the position. Let us say this is your current. Then current will be pointing to the position that is just before the position of insertion. So your actual position of insertion is this. Your current is pointing here. What will you do? You will make your new node's next pointer. This will point to the position that is pointed by present current pointer. That is what you are doing here. After that, what is the next step? Your current's next pointer, this should be made to point to your new node. For this, your current pointing next, this will be equal to new node. So whatever be your new node, that is what your current's next should point to. So now after current, you have the new node. After that, you have whatever was previously next node of current node, which means your new node is inserted at the correct position. What should be the last step? Once this is done, your complete procedure is done and you can return your head node. Why are you always returning head node? The reason is head is the node that identifies a linked list. Whenever you have a linked list, your head node will identify the linked list. So you added this in the linked list and then you are returning the head saying, I modified the linked list and here is the head pointer to this modified linked list. Let us just go through this function once more. We'll take a quick look so that you stay very clear. In the function, you have three inputs. One is head pointer of the linked list. Then you have the position at which you want to insert 0, 1, 2, 3 something. And then a value, an integer value generally that you want to insert. If you want it's a character value, that's also fine, whatever be the value. First step is to create a new node which is having the data as value. After that, in case the position is 0, that is if it is beginning, you'll treat it as a special case and handle here. How are you handling? Whatever be the next pointer of the node, that is the new node, that will point to present head, that is whatever is the first node. After that, head pointer will be made to point to the new node, which means new node becomes the new head. After this, you can return head. New node will be at the beginning of this node, of this linked list. Otherwise, in case position is not beginning, then you can handle it as a single case. In that case, what do you want to do? You should first traverse till one position less than position of insertion. For that, you will keep a current pointer which will start from head. You will have an index which will keep track whether you reached one position lesser than the position to be inserted. In the while loop, you are going till the position which is 1 point less than the one, and then whenever you reach that position, you will come out of the while loop. One case you are handling here is in case you came out of the while loop because you reached the end of the node, then the position that is provided is invalid. You will simply return the head, or you can also say it is invalid and then return the head. In case it is not, then the position is valid. What will you do? You will make next pointer of the new node point to whatever is previously pointed by the next pointer of current node. Current node means whichever be the pointer you are using to point to the position before the position of insertion. After this, current pointing next is made to node. That is, the next pointer of current node will now point to node. That is when you have the linked list like this. At this point, your procedure is completed. You will return the head. What is the time complexity of this? Time complexity is you are going from one end of the linked list till the other end. That is, in worst case, you have to go till the other end. That is, if the position is the last position to be inserted, you have to go till the end of the linked list. In that case, your time complexity will be order of n. So worst case time complexity is order of n. What about the space complexity? Space complexity is order of 1 because you are not using any additional space other than the space used for creation of new node. And this one, the creation of new node, this is not dependent on the input size n. This is why space complexity is order of 1 and time complexity is order of n.